We have given function and we need to find maximum, minimum and inflection points. First, like always, we find the domain of this y function. We see that we have here addition, subtraction, multiplication and the power. It means the domain will be all real numbers. Next, we have to find minimum, maximum. We will use the first derivative test. So we need first derivative of our y function. Y prime is equal. Derivative of negative 2x to third is negative 2 times 3 times x to second power plus 9. Derivative of 9x squared is 9 times 2x minus derivative of 12x is 12. A derivative of constant is 0, so we don't have to write this. So y prime is equal negative 6x squared plus 18x minus 12. We have first derivative. Next, we have to find critical values. So we have to check when y prime is equal 0. If and only if negative 6x squared plus 18x minus 12 is equal 0. We have quadratic equation. First, I will factorize negative 6. So we have in parentheses x squared minus 3x plus 2 equals 0. I divide both sides by negative 6, so we will have x squared minus 3x plus 2 equals 0. Now I have to find two numbers which multiplying by each other give me 2, and when I add them I will have negative 3. So it will be x minus 1 and x minus 2, because negative 1 times negative 2 give me positive 2, and negative 1 plus negative 2 is negative 3. So this is equal 0. Because we have multiplication here, the left side will be 0 when x minus 1 will be 0 or x minus 2 will be 0. So we have x equals 1 or x equals 2. We have critical values. Now we will draw the graph of our derivative, first derivative function. So let me draw x number line. We have two roots, 1 and 2. This is quadratic function. The graph will be parabola, up and down, because we have negative coefficient before the x square. And now we see that this part is above x-axis, so has positive values. This part is under, so has negative values, and this is under, so this is negative values. This is our y prime function, negative 6x squared plus 18x minus 12. When we change the sign from negative values to positive, we have maximum. When we change sign from positive values to negative, we have minimum. So now we have to find this point. We have x equals 1 and x equals 2, so we have to find the y coordinates. So for x equals 1, y of 1 is equal, we need to replace in our y function x by 1. So it will be negative 2 times 1 to third power plus 9 times 1 to second power minus 12 times 1 minus 1. This is equal negative 2 plus 9 minus 12 minus 1. So we have negative 2 plus 9 is 7, minus 12 is negative 5, minus 1 is negative 6. we have our minimum. First coordinate is 1. The second is -6. This is our minimum. Next, we have to find our maximum. X equals 2, so y of 2 is equal. We need to replace x by 2. So we have -2 times 2 to third power plus 9 times 2 to second power minus 12 times 2 minus 1. This is equal -2 times 8 plus 9 times 4 minus 24 minus 1. This is equal -2 times 8 is -16 plus 36 minus 24 minus 1. This is equal -16 plus 36 is 20, minus 24 is -4, minus 1 is -5. So we have our maximum point, 2, -5. This is our maximum. Next, we need to check if our function has inflection points. So first we need the second derivative. It means we have to find the derivative of first derivative. So y this is equal, we have -6 times 2 times x plus derivative of 18x is 18. Derivative of -12 is 0, so we don't write this. So the second derivative is equal -12x plus 18. Next, we have to set our second derivative to 0. So y this is equal 0 when if and only if -12x plus 18 is equal 0. So we have -12x is equal -18. We divide both sides by -12. Negative and -12 will reduce, so we have x equals, negative by negative gives us positive. 18 divided by 12, it will be 3/2. So we have x. Now we have to check if in this point our second derivative change the sign. If change the sign is small distance from 3/2, it means we will have inflection point. So to do this, the easiest way, in my opinion, is to draw the graph our second derivative. This is linear function. The graph will be straight line. Because we have negative coefficient, it means our line will go down. And we have x equals 3/2. We are going down. So we have, and this part is under x-axis, so has negative values. This part is above, so have positive values. We change the sign from negative to positive when we pass 3/2. It means we have inflection point for x equal 3/2. Now we have to calculate this. Y of 3/2, it will be -2 times 3/2 to third power plus 9 times 3/2 to second power minus 12 times 3/2 minus 1. I just replace in our y function x by 3/2. So this is equal -2, we just copy. 3/2 to third power is 27 over 8 plus 9 times 3 over 2 to second power is 9 over 4 minus 12 will reduce with 2, so will be 6 times 3 is 18 minus 1. So this is equal negative, we have negative 2 times 27 over 8. We can reduce 2 with 8 will be 4. So we have negative 27 over 4 plus 9 times 9 is 81 over 4. Negative 18, negative 1 is negative 19. This is equal negative 27 plus 81 is equal positive. They're the same. And we have negative 27 plus 81 is 54 minus 19. We can change improper fraction to mixed number, so it will be 54 divided by 4 is 13 and 2 over 4 minus 19. This is equal 13 and 1 half minus 19. This is equal negative 5 and 1 half. So our inflection point has coordinates 3 over 2 and negative 5 and 1 half. We can rewrite this. 3 over 2 is 1 and 1 half, negative 5 and 1 half. This is our point of inflection.